Yes, ma'am.
Okay. So they told us the center is at 4, -1. And then they told us there's a focus at 4, 2. So I'm going to put an F by it. And then they told me there's a vertex at 4, 1. So let me ask y'all a question, because the first thing you should have done is figured out what kind of conic this was, right? If I give you a center where the vertex is up and the focus is above that, we talked about this yesterday. Your conics always wrap around the foci, right? So this should open like this. If the center is down here and it's opening away from the center, what kind of conic is this? Hyperbola, good. Are y'all okay with that part? Yes, no, yes, no. Y'all are okay? People at home?
Yes.
I'm good.
Okay, thank you. If you are not good, you have to ask. No one's going to make fun of you. You get extra credit for asking questions. It's a hyperbola. So let's talk about a hyperbola. A lot of y'all, like when you look at stuff like this, you just stare at your points. Write down what you know about a hyperbola. That's how you problem solve. Write down what you know. We know it's x minus the center. So what was the center x coordinate? 4. X minus 4 squared. Ooh, it's not x minus 4, but that's okay. If it's a vertical hyperbola, what should come first? The y. So good, I'm going to put the y over here. You did the same thing I just did, but I caught it, so that's good. What's the y coordinate of the center? +1, so what do we write in here? Oh, you're saying the center, I asked what the y coordinate of the center was. -1, so you're telling me I should put +1, right? All right, my baby's at home. One of y'all is going to answer this. What's the only thing we're missing?
The axis.
Good, the axes or the radiuses, right? The radii. So what goes underneath the y? Which one? The vertical or the horizontal radii? The vertical, so that would be b squared, right? And the horizontal radii goes under x, so that would be a squared. Go look at your picture. Which radii do we have? Good. You should be able to see your vertical radius from the center to the vertex. How much does it go up? So what's 2 squared? Okay, we should have been able to get this far. Don't sit there and stare at your 3 points like you don't know what's going on. I'm looking at y'all because y'all are here and I can see you doing it. I'm sure y'all did it too. I'm sure some of y'all sat there and didn't even try it and waited for me to do it. Yikes. Y'all didn't have that luxury. What are we missing? The horizontal radius. You have no idea what it is. You can't see how far this goes left or right. Right? Okay. So to find it, what is the third thing that we haven't used that yet that's just chilling up here? The foci. If they give you foci, y'all, use your foci formula. Think about what you know about a foci. If this is a hyperbola, what do I know about the foci? How would I find them? A squared plus, because you do the opposite, we're working backwards, b squared equals c squared. We don't know a squared. That's what we want to find, right? But what was b squared? Good. A squared plus 4. And now let's talk about this. I told you yesterday, c represents the focal distance, right? What's my c value? How do I get from this center up here? 3. So what's 3 squared? There you go. So what should a squared be? So a would be the square root of 5, but listen to me carefully. You don't even need to find a. We need to find a squared. So what would a squared be?
Miss Poole.
Yes.
Where did you get the 9 from?
Right here, Drakey. How much does it go up to get to the foci? 1,
okay.
2, 3. So 3 squared is?
9. Okay, thank you.
No, you're welcome. That was a good question because I'm sure other people were wondering too. Good job. Extra credit point. Are y'all okay with that one? so sad that I have spent this much time on hyperbola. Wow. It's okay though. Are we good? Are y'all sure? Some of you don't look sure. I can't see y'all's pretty faces. People at home, are y'all okay?
Yes.
All right, ask me a question if something doesn't make sense. Let's look at number 2, and then we're gonna hold off for today. Draw my coordinate plane. All right, for number 2, we have foci at 5, 1, and negative 1, 1. So I'm going to go over 1, 2, 3, 4, 5, up 1, and then negative 1, 1. And then if it was me, I would have put F's here so I knew what those were. Some of y'all just put a bunch of points, and then it was confusing to see what was what. Now this one really should be almost easier. It says the length of the major axis is 8. I'm making sure I graphed these right real quick. I did it wrong on my paper. Catch mistakes every day, Daniel, even me. All right, if the foci, let me ask y'all about these foci. Are they horizontal or vertical? Yeah, horizontal. It's not a trick question. They're side by side, correct? Okay, if the foci are horizontal, that means the whatever shape will be horizontal because it should wrap around those, correct? All right, so go read the next part. It says the length of the major axis is 8. So the major axis has to be 8. If the foci are horizontal, what axis do you think is the major axis, horizontal or vertical? Horizontal. So this horizontal axis should be 8 long. Before I even go do that, what do you guys know about foci? Yes. Okay, good. Y'all were sitting here staring at these. Y'all know what to do. They're saying they're equidistant from the center. So where would the center be? Good. Oh, so proud of y'all. 2, 1. That's your center. We okay with that? All right. So now that you know your center, my horizontal axis is supposed to be 8 units long. So what should I do? Good. Go out 4 from the center each way. So 1, 2, 3, 4. Here's one vertex. 1, 2, 3, 4. And then let me ask y'all a question. It's supposed to open around the foci. So what kind of shape is this going to be? An ellipse, because it'll open in and they'll touch, right? It's not 8 each way. The axis is 8 total, so that's 4 each way. That's the part that's tricky. I'm wondering if that's, I don't even know what I did on mine. Something wrong. Doesn't even look right. Yikes.
So Ms. Poole?
Yes.
Most of the time, if it gives you like the 2 foci, do you automatically assume it's going to be an ellipse?
No, because it gave you a focus in number 1 as well. So no,
If it gives you like 2 of them, like you for number 2.
So if you look at number 4, it gives you 2 foci, but when you sketch it, they open apart.
Okay.
Okay. Good question. Very good question. All right. So from here, let's write what we know. It's an ellipse, so we know we should be adding in the middle, right? Okay. What's the x coordinate of the center? 2. So what do I write? -2. What's the y coordinate of the center? So what do I write? -1. And then let's see if we can figure out our axes or our radii. What is my horizontal radius? We should be able to see that. Good, I went out 4, right? So what is 4 squared? There we go. And so Maddox said we're missing, I said your name, I hope that's okay. I need to give y'all like cartoon names or nicknames or something, since we're not supposed to say y'all's names anymore. Crazy. All right. We're missing the vertical radii. We have no idea how far up and down this goes, right? But what he just said was, okay, it's just like the last one. You gave us the focal length. What's my focal length? My focal length. 3. It goes over 1, 2, 3 each way, right? So how do you find the foci of an ellipse? Good. You do the opposite. A squared minus B squared equals C squared. What was my A squared? Do we know B squared? No. But what was C squared? 9. Because it was 3. 3 squared is 9. So 16 minus what number gives me 9? Good. So B squared should be, wait, is that right?
I thought it was 5 because it's
It's 7. 16 take away 7 is 9. 16 take away 5 is 11. But you could totally solve if you can't think about it that way. But B squared should be 7. So your equation, Daniel, I ain't getting nothing close to that. Yikes. I don't know what I did on my paper. That's what I get, Maddox, for doing crap in the car. That's your equation for number 2. Are we okay with those? Sort of. Okay, I can take sort of. I'm okay with sort of. All right, I never do this. I don't know why I'm feeling so nice today. I'm going to ask y'all what y'all would rather do. I feel like this is a terrible decision because I know which one is the better choice. So everybody just listen. I'm going to give you a choice here. We can stop here, start parabolas, and then you will finish this worksheet for homework tonight. So you have, Cody's looking at it, he's like, well, that's a great option. You would have to do 3 and 4, and you would have to go back and sketch each shape in the middle section. I shouldn't say each shape. You would have to go back and sketch 5 and 7 and see if you can write the equations of the asymptotes without me. That's your first option. Okay. Second option, I show you how to do asymptotes really quickly. I still need to start parabolas today, but you would finish the worksheet for homework. Either way, we're not going to get through parabolas because I just spent 48 minutes on the stuff from yesterday, which means your test is now Tuesday. I don't think we've gotten through a single unit where I haven't had to push crap back because y'all weren't taught how to problem solve. I'm going to have to trim that out of my video. What do we want to do? I'm going to be honest, I think the first option is the best option. You trying to figure out the asymptotes on your own. It's not hard. You would have to go sketch each hyperbola. What can you use to sketch the hyperbolas? Desmos. You could use graph paper, but you can also use Desmos, and you already have the equations for them because I showed you my key. So you know if the equations are right. So you would have to look on Desmos and see if you can find the equation for the asymptotes. I think that's our best option. Me start parabolas, you do that tonight. I mean, you would have 4 questions for homework, 3 and 4, and then you'd have to go try to find the asymptotes of 5 and 7. Are y'all okay with us doing it that way? I will go over the asymptotes tomorrow. I promise we'll put stuff in our notes and everything. People at home, what do we think? Y'all are very quiet.
I agree. Do that option.
Are you sure?
Yeah,
Yep, I agree.
Natalie or Mary?
it was Mary.
Okay, I couldn't tell. We think we could figure out the asymptotes on our own. It's not hard if you go look at it in Desmos. You'd have to write the equation of the lines for each asymptote. 5 and 7, because it also asked for asymptotes. But this way I can start parabolas and we can just finish it up tomorrow. Your homework won't be on parabolas though. So your parabola homework will get pushed to tomorrow. How does that sound? Are we okay with that? Anybody else from home have an opinion? None of them have an opinion. All right, let's do it. Would you like me to just show you really quick how you would find the asymptotes of 5? Like get you started? Would that help? Yes? Okay, Cody, I'm gonna talk to you. Do you want me to show you in Desmos or up here, and y'all can do it on Desmos later? Up here, okay. I knew you would choose wisely. All right. Just really quick before I start parabolas. Now y'all gonna have to, I'm gonna have to go into Canvas and change my plans. It's so much work. All right. For number 5, the equation of the hyperbola we got off of the homework. So please, no one ask me what I'm doing. I'm talking about number 5 on the homework. Bless you. Was this, do y'all agree? We looked at my key, all that jazz, and y'all seemed okay with it, right? Yes? Okay. So where's the center of the hyperbola? Because number 5 was a hyperbola. -4, 3. So I'm going to go left, 1, 2, 3, 4, up, 1, 2, 3. There's my center. Bless you. What's my horizontal radius? Good. This is my horizontal radius squared. So the radius is 3. So I'm going to go 3 left, 3, 1, 2, 3, counting's hard. Right. I said that backwards, but you knew what I meant. Are y'all okay with that? What's your vertical radius? The square root of 1 is 1. So this goes up 1 and down 1. Now, bless you. Now, you're fine, girl. I think it's funny. This is what you have to remember. A hyperbola is the opposite of an ellipse. It's a broken up ellipse. So your ellipse would be in this little box right here if we kept it together. Showed y'all this yesterday. I'm going to show you again because some of you asked me why your homework had little boxes at the bottom. Look at 11 and 12. There's like a bolded box in between the hyperbolas that the asymptotes pass through. Ooh. All right. What kind of hyperbola is this? Horizontal or vertical? Horizontal. Good. So when you graph this one, it's horizontal because the x comes first. So our hyperbola is going to look like this. Does everybody agree with that? Okay, so when you go draw your asymptotes, you're going to try to draw them as straight as you possibly can. What the homework is asking you is to find the equation of the line for those two asymptotes. You've learned how to find equation of lines in Math 1. I mean, you really could go watch my Math 1 videos. You'll see me throw markers at kids and fuss at kids, but yes, Math 1 children are wild. Good. So review for Math 1, the slope. If it goes from the center to the corner is up 1 over 3. So that would be y equals 1/3 x. What's the slope of the other one? Negative 1/3 because it goes down 1 over 3. So what's the only other thing you would have to find? The y-intercept. And if you're looking on Desmos, should be pretty easy to see. Asymptotes are not hard. You learned how to find equation of lines in Math 1. The problem is you don't do lines in Math 2. I don't think y'all got to them in Math 3. So some of you gonna have to do some recollecting, okay? Yes, smarty pants. I'm not repeating that though because I want them to have to think for themselves. But yes, very good, Maddox. All right, are we okay with that? So there's no confusion. I'm saying it in the middle of the video before I start notes. Do not go off of Zoom and not start the parabola notes because we need to start parabolas today. Your homework tonight is not the Delta Math. That'll be classwork tomorrow. And you'll have a different homework. Or we'll do the worksheet as classwork and the Delta Math will be homework, vice versa, whatever. I actually don't think I'm gonna have to push the test. I'm gonna really try not to. Your homework tonight is off the same ellipses hyperbolas worksheet. We're doing number 3, number 4, and then you're gonna find me the asymptotes for 5 and 7, correct? That's not a lot of homework. Y'all know I gotta get my little makeshift cones. I was so proud of myself for making these because Miss Kane took mine. It's like a little party hat. How, huh? No, because I need to actually be able to cut it. So who remembers from yesterday how we slice a cone to make a parabola? Vertically. If I cut this anywhere vertically, and I don't have my scissors and I'm not going to go get them. See how strong I am. I'm going to rip it. If I cut this vertically, everybody agree the shape on the side of the cone is a parabola. It's just janky because I ripped it instead of cut it. Okay? So we get a conic parabola when a cone is intersected vertically by a plane. Everybody okay with that? All right. So the next thing you need to know, conic parabolas can be vertical or horizontal. How is that different? Yes, that's what I'm asking. Yes. How is that different from parabolas when we talked about quadratic functions? How's it different? Good. So what they're saying in class online, babies, when you talk about functions, you can't have a horizontal parabola because why? Let them answer. Why can we not have this as a function, math or online people? I almost said math 1. My math 1 kids could tell you this is not a function.
Because it can't be negative.
Okay, when you square something, you shouldn't get a negative, so this bottom part wouldn't exist, yes. But the main thing I'm looking for, is this a function? I'm asking them. Hello? Is this a function?
It has to be the same on each side when you cut it in half, right? Or no?
Well, I'm not cutting it in half. I'm asking y'all if this is a function.
Yeah.
What?
No.
Frank!
I said no.
No, y'all, you can't have 2 different Y values. I'm gonna go get y'all's old teachers. Lord Jesus, this is not a function. I'm praying for them. Not a function. However, are we talking about functions anymore? No, good. The correct answer is no. Conics are not functions. They are shapes. Does everybody see the difference? So if I turn this cone sideways and cut it vertically, does everybody agree my parabola would be horizontal? Example, I just cut this one. Oh, look, I turned it sideways. Does everybody see this horizontal parabola? Y'all can see it, right? Okay. Conic parabolas can be vertical or horizontal. So that is how they are different from quadratic functions. Y'all's warm up tomorrow. I'm going to give y'all a bunch of different pictures and ask you if it's a function or not. Maybe not y'all, maybe them. I don't know. All right, conic parabolas can be vertical or horizontal. So the last thing you need to know before we draw a picture and write the equation, all points on a conic parabola are equidistant from a given line and a fixed point. Let's zoom this in. Cody, are you proud of me for not using the green?
Yeah.
I remembered today. Equidistant, because equi is a prefix, which means the same. Equilateral, equidistant. It's another equi prefix. I took Latin in college. Equifax, sure. Good job, Kevin. Extra credit. I like that. That was funny. All right. The given line that the points on the parabola are equidistant from. This is called your directrix. That's a brand new word. You shouldn't have seen it before. This is not new though. The points we talked about yesterday, that hyperbolas and ellipses were equidistant to. What were those points called? Good, foci. But now look at this. This just says point. So what is it going to be called? Focus. Very good, children. Oh my God, I can't spell. Directrix. Directrix. Is that too fast? Sorry. Do you need me to spell it again? Yeah. Okay, Directrix. Directrix. Ow. All right, people at home, are y'all okay?
Yes.
All right, let me show you a picture. I'm gonna show you this one first so I can drill into y'all's heads this ain't a function. Get y'all children. Does everybody agree this is a parabola? Does a parabola have a center?
No.
Why not? You're right, it doesn't. Why not?
Because it goes on forever.
It goes on forever and it's open. A shape cannot have a center unless it is a closed off shape, unless it's a polygon, right? So this is an open shape because when we cut this cone vertically, it's now open, right? So parabolas do not have a center. What they do have, you said the word, can you say it again? Good, they do have a vertex. That should not be news to y'all. Y'all did parabolas and math too, didn't they all have vertices for a vertex? Shouldn't say vertices because it's just one. All of these will have a vertex. So your general form isn't going to tell you the center, it's going to tell you the vertex. There we go. It'll give you the point that your parabola turns at, starts at, okay? Your focus is going to be somewhere up here. We're going to draw a better picture in a minute. That's nothing new either because we learned yesterday that cones wrap around the focus, right? That's what they focus around. Then the other thing, the directrix. I like to think of it as a reflection line because y'all are usually actually pretty good with transformations when I get done teaching it to you. So your directrix is your reflection line. Any point on this parabola, and I probably should have drawn a better one, so let me draw you a better one. Any point that I pick on this purple parabola, and it still wasn't great, but just watch, will be equidistant to the focus and the directrix. Any point. It revolves around these two things. Does that make sense? This is its reflection line. So it's always going to be the same distance from that as it is from the focus that it is wrapping around. That is the main thing you need to know about conic parabolas. No, just a conic parabola. We're not talking about quadratic functions. We're talking about the cones. Are we okay with that? Are y'all sure? Yes, no. Give me something. Y'all look bored.
I don't know if you said this in the thing from Canvas, but how is it equidistant? Because it looks like all the points with just kind of different.
Yes, I drew this. I'm a terrible artist. This does not look equidistant. Every single one you have on a homework, every single one you ever like see on anything will look equidistant. If we graphed it in Desmos, it would be equidistant. Yes. It's not easy to see when you have someone who's not good at drawing it. Are we okay? All right, I'm gonna try to make this next one nicer. Let's draw a picture, then we're gonna learn what the equation looks like, and then we will be done for today. We'll do all the examples tomorrow, okay? All right, my picture. I'm not gonna use green, so I'll use green as the graph part. I am gonna make sure I do nice ordered pairs to make sure yours match mine. Are y'all okay that I did a vertical one? I didn't even ask. I feel like I maybe should have asked. Y'all okay that I did a vertical one? Okay. People at home, what about y'all? Anytime I ask a question, it is also directed at y'all. Y'all okay that it's a vertical one? Do you want a horizontal one too, or you're fine with it being vertical?
It's good.
It's good.
It's fine being vertical. I don't care.
Okay. Thank you, Drake. All right. My baseball boys always be answering. Love that. All right. What's this reflection line called? Directrix. You're about to see why they're equidistant. I made you a good one. Okay. What's this point called that it wraps around? The focus. It's just one, so focus. What is this point called? Okay, yes, it is the y-intercept, but thank you. Yes, that's what I'm looking for. We don't necessarily care about intercepts with conics because they are not functions, they are shapes. So that is where y'all mess up with these. My pre-cal kids usually dislike parabolas. You guys are okay with everything, and then we get to parabolas and you don't like them, and here's why. Y'all are used to thinking of them as a function. They're not a function. We're not talking about functions. We are talking about a shape. So it's just a U shape, okay? Don't think back to quadratic functions from math too. These are not the same thing. They have some similarities like the vertex, but not the same. Are we okay with that? Cody, good? All right. So, I'm gonna get a different color. You care if I say your name? Okay. Kendall asked, so it's always equidistant. I said yes. Here's how I'm going to show you. You ready? Trying to think how I want to show you. All right. This picture is going to look a little crazy when we're done with it. Whoever said theirs looked crazy yesterday, it's going to look a little crazy today too, okay? What is this distance that you guys see on this graph from the directrix to the focus? 4. What is the distance from the focus horizontally to the parabola? Not a coinky-dink. If those don't match, your equation is wrong. You did something wrong. Do we understand that? Okay. The total width that goes through the focus, this is called the focal width. It also has a very funny name that I'll say because I'm immature and I think it's funny. It's also called the lattice rectum. Does anybody know what a rectum is? What's a rectum? Your tushy, your butt, from one cheek to the other cheek. That is your rectum. Focal width. What do you guys notice the focal width is? Okay. What conclusions can we draw? What is the focal width very similar to? The diameter or the axes, right? Very good. What is the distance from the focus to the parabola very similar to? The radius. Very good. The diameter should be double the radius. So here's what I need you guys to know. Your radius, I'm not going to write radius because there's not a radius with an open shape. Radii come with closed shapes, okay? Your radius, though, is always the same length as the focus to the directrix. Does everybody see that? Okay, so this is what you need to know. I'm around. The distance from the focus to the directrix is always half of the focal width. Always. If yours doesn't look that way, you did something wrong. All right, kiddos, so here's your reason why. One more time, because we just proved why. The focus to the directrix is the same length as the radius. Can't really call it a radius because it's an open shape, but think about it like a radius, okay? Well, that entire width is going to be double that then, right? So if I give you the width and I'm asking you for the distance between the focus and directrix, you should know it's half. Are we okay with that? Because it should be the same distance as the radius. Does that help a little bit? Okay, good. That's the best way I've ever explained it. I'm getting better the older I get. Are we okay with this picture? Okay. Look at the picture. I want you to write down this equation. We will talk more about it tomorrow. That was not an invitation to pack up because I have 4 minutes. I know how y'all be. Here's your 2 equations you could have. I'm going to stop for a second. Why do you think I said 2? Vertical and horizontal. Very good. So let's write down this first one. I will show you where this comes from tomorrow because it looks very scary, but it actually comes from vertex form of a quadratic function. I will show you tomorrow, okay? Which one do you think this is? Why vertical? Back it up. I'm not saying if you're right or wrong.
Because y has the a coefficient.
Okay, so the A is with the Y, but there's really another reason why this is vertical. You were right, Cody. Don't second guess yourself. You can tell me. Yes, X is squared. If the X is squared, this is a vertical parabola, just like the ones you saw in math 2. But listen, we're not talking about functions, we're talking about a shape. Okay, this is a vertical parabola. So what do you think the only difference is with a horizontal one?
Y squared.
The Y is squared, so you guys will flip them. So watch, the Y and the K will be over here now squared. The A will be over here with the XH. This is a horizontal parabola. And this one is horizontal because the Y is squared. So tomorrow, don't pack up, not an invitation, pack up. I will show you how we get these from vertex form of a quadratic from math 2. Because if you can think about it that way, it's easier for you to remember the equation, okay? Yes.